The Kjeldahl method was developed in 1883 by a brewer called Johann Kjeldahl. The protocol is built on the principle that strong acid helps in the digestion of food, so that it releases nitrogen, which can be determined by a suitable titration technique. By observing the nitrogen concentration of the food, the amount of protein present is then calculated. This method is particularly ideal for insoluble proteins, protein in foods, and protein covalently immobilized on chromatographic supports. It is usually considered to be the standard method of determining protein concentration. The Kjeldahl method process can conveniently be divided into three important steps or principles, which is digestion, neutralization, and titration. For the digestion, the purpose of this step is to break down the bonds that hold the polypeptide together by digesting the protein in sulfuric acid with anhydrous sodium sulfate and a catalyst, which can be selenium, mercury, or copper salts, and convert them into simpler chemicals such as water, carbon dioxide, and of course ammonium sulfate in the form of ammonium ion and sulfate ion. For the second part of this method is distillation, where a small quantity of sodium hydroxide is added to convert ammonium sulfate to ammonia gas, which will be moved into receiving flask containing boric acid. This will convert boric acid into borate ion and ammonia into ammonium ion. For the last part of Kjeldahl method is the titration part, which the nitrogen content will then be estimated by titration of the ammonium borate form with standard sulfuric or hydrochloric acid and determine the endpoint of the reaction. The concentration of hydrogen ions required to reach the endpoint is equivalent to the concentration of nitrogen that was in the original sample. Once the nitrogen content is determined, it is converted to protein content using appropriate conversion factor. So as shown here is the calculation that we need to use in order to find the nitrogen percent in the sample. As the Kjeldahl method does not measure the protein content directly, a conversion factor F is needed to convert the measured nitrogen concentration to a protein concentration. So a conversion factor of 6.25 is used for many applications. However, Kjeldahl method is not suitable for compounds containing nitrogen in azo and nitro groups or in rings quinoline, pyridine, or nitrate, as the nitrogen cannot be converted to ammonium sulfate, which is compulsory in the Kjeldahl method.